Hi everyone, I am Satyapriya, Assistant Professor, Department of Physics. Now we are going to discuss about the topic DT based video on the topic simple cubic crystal and then design thinking based on building block of innovation. And then first of all, what is crystal? Crystal is nothing but regular arrangement of atoms or molecules called as crystal, and then three-dimensional building block is called as the crystal structure. At its corner, a simple cubic crystal is the most basic three-dimensional repeating unit found in a crystallography. It is a fundamental concept that help us understand the arrangement of atoms in solid materials. First of all, atomic arrangement, and then simplest 3D lattice, and then rare in nature. We'll briefly discuss about this atomic arrangement. Atoms are positioned exclusively at each corner of the cube, forming a high symmetrical structure. And then simplest 3D lattice, also known as primitive cubic, it represents the absolute minimum number of atoms required to define a repeating unit in 3D space. And then rare in nature, while simple this structure is rare in nature due to this relatively low packing efficiency. Polonium is the one of the few elements known to exhibit this crystal structure under specific condition. And then next one is visualizing the simple cubic structure. Understanding the characteristics of a simple cubic crystal helps illustrate its element simplicity and unique properties. First of all, we discussed about atoms per unit cell, and then coordination number, packing factor, and then atomic radius. First, we briefly discussed about the topic atomic atoms per unit cell. Each of the 8 corner atom is shared by 8 adjacent unit cell, resulting in a net of 1 atom per unit cell. And then coordination number is nothing but nearest neighboring atom. That is, each atom in the simple cubic lattice has 6 nearest neighboring atoms located directly along the axis of the cube. And the next one is atomic radius. The edge length A of the cube is precisely twice the atomic radius, that is A is equal to 2r, and then r is equal to a by 2. This is the value of simple cubic system, the atomic radius. And the next one is packing factor. In this case, packing factor, the formula is the volume of all the atom in unit cell divided by total volume of the unit cell. First of all, with only absolute 52% of volume occupied by the atoms, it's considered loosely packed structure compared to the more common cubic structure like BCC or FCC. BCC is nothing but body center cubic structure, and then FCC is nothing but face center cubic structure, which have higher packing densities. Okay. Next, this is the DT based topic. So empathize, define, and then ideate, and the prototype testing. And based on this category, we will discussing the next topic, the simple cubic as a simple cubic structure related to design thinking based as a simple cubic crystal with the fundamental characteristics provides a compelling metaphor of the core principle of design thinking. And then just as simple cubic behind with basic repeating unit design thinking encourage them starting with clear fundamental problem statement, and these are executed by the repetition, and then the crystal identical unit cell repeat to build a large structure. Similarly, design thinking on iterative prototyping and testing. And then structural symmetry, the structural symmetry in this case symmetrically through the phases while maintaining the flexibility. These are the under the simplicity, and then repetition, and then structure and symmetry. And then from the atoms ideas building the simplicity, 1 atom per unit cell represent focusing on one core idea or hypothesis per ensuring the clarity and testability. And then connecting. Okay, next one is the case study Polonium simple cubic crystallizes innovation lesson. These are the and then unique in simplicity and then breaking through and then minimalism. These are the under the case study on the Polonium topic. And then in this case the finally conclusion, start simple, build and then connect idea symmetrically, and then these are the under the conclusion. Before that the case study on the Polonium, these are the based on the simple cubic structure, unit atomic number and then atomic packing factor and then atomic radius we calculated. Okay, next class we discussed about the case study on briefly discussed about case study topic on Polonium structure. Okay, thank you.